depending on what people but Justin asked us to talk about like a lot of the libraries are written in Rust right now, like the signature library, everything. Rust is a language that doesn't play well with others, not as much as Go, but the problem is Go is a big target as well, so that makes things even worse. So I was thinking the first thing is I could explain maybe a bit what issues we have at least in Zim to integrate with Rust libraries. And it's just summarized here. Like I just have very quick slides, but I can get into the details if you have questions. And the problem is that Rust is very slow to compile. That's the problem, and that means that when we compile Zim for the first time, what it does it calls Rust to compile all the libraries. And Zig itself, the Zig compiler, the Go compiler is also quite fast. But then you have this indirection where you spend maybe a good 10 minutes downloading everything and compiling it. Potentially running out of memory on more constrained machines. So I would say for us, Rust is not exactly godsend. And what we're a bit worried about, and why did I write compiler version? It's because initially we tried to say, okay, we're going to compile. We support like 2 ZKVMs, actually 2.5. So we compile the bindings for this ZKVM in one library, then the binding for ZKVM in the second library, then the third ZKVM in the third library, and then we have the libp2p thing that we're trying to get rid of, but currently we use it, like we have glue, and then I think I'm not forgetting anything, but what we would add the what's that called, the signatures and potentially other things on top of that. So that means we need to compile things even further. And the problem is when we start doing static libraries, because we just want to, in terms of release engineering, we just want to release one binary that we can put anywhere. We don't want to have multiple shared libraries. Rust will duplicate every symbol, which means you get duplicate symbols, like very easily. So you can't really have one library per binding. So you need to put everything in a single library. And then you start having other problems. Luckily, we don't have them yet, but I'm sure it's going to happen. Is that Rust evolves very fast, like the language. There's a lot of incompatibilities between the versions. And I think at some point we're going to run into the problem where one binding expects one version of the language and another version that are not compatible, like it just doesn't compile. So for us, this setup is really impractical. Yeah.
To be noted, like on the cryptographic side of things, we are trying to always target the very last version of Rust. So this can also pose some problems for you, because like for performance reason and all of this, each time there is a new version with my feature, for example, like in the very last version of Rust, you have nice constant stuff generics where you can put some assertion inside, and to gain a very tiny performance stuff, we always move to the last version.
But when you say the last version, do you mean the nightly?
No, the last table.
Last table. Okay.
Last table.
This table is okay, I think.
But you can have problem because I imagine that with the underlying things that we compile, they are not all targeting the very last version, and so I imagine that this can be also a source of problem for you.
So absolutely. Just to clarify, what Rust library are you using besides cryptography? libp2p?
libp2p and everything, like because we do ZKVM proving. So we have a binding to OpenVM, to Zisk is in progress. We still have Powder, even though it's no longer a thing, and RIS0.
Do you have plan to migrate libp2p to Zig? Because
yes, that's what Ben among other people are working on. But let's say for DevNet, it's not ready for its prime at the moment. So we need to be able to, as soon as we can get rid of the libp2p stuff, or find any other library that's not Rust, that would be.
You can use NIM libp2p.
It's not a go to the next slide.
No. Everybody's laughing, but I'm not taking it as a joke. Yeah, that's
because NIM can use zigcc now. You type
really?
NIM zigcc and you compile NIM through zig.
Wow. Okay. Now we're talking.
Isn't Zig trying to move away from using like the whole leanVM stack?
Yes.
So that kind of in the future.
Already done, no?
Yeah, it works now.
Yeah, it works now. Yeah.
So roughly how many Rust libraries are we talking about here?
If you want, I can give you a brief context on why we did this choice and what we have right now. So basically, like all of the cryptography is much easier to develop in Rust because we have first pq2-03 and we have all of the cryptography available, even if it is not pq2-03. We have like a very nice parallelization, crates, rayon, and all of this. So we developed basically the XMSS signature scheme with Rust. As we discussed with Guillaume yesterday, I think that as this is quite a reasonable crate, this is not a problem to port that to other languages, C, C++, Zig, Go, whatever we want, because, for example, I have just done the migration to Python to write the spec, and once you have like the code in Rust, there is not much work to port to another language, but this is reasonable. Then we have everything related to the leanVM, and that is more complex. Why? Because we have leanVM, but we have like all of the primitives before that. So we have like the finite fields, we have like the PCS, the hair builder constraint, and all of this stuff. So this is more complex, and this is also written in Rust. We could also have planned to migrate that once this is stable to other languages. For example, having like a leanVM in Zig, in C, a bit like this is done with a KVM, where you have one in Go, you have one in Rust, and maybe you have
but those were external people that asked for grants.
Maybe this is also an option. I don't know. Like I have not that much context on this. My recommendation is that right now all of these are not stable. For example, like the XMSS library, this is quite stable, but I think that there is a session today to talk about like the new encoding scheme and how to render it more ZK friendly. So there is probably big change. So this is probably not the right moment to migrate everything. Also not, of course, like the leanVM, because this is not stable at all. So this is not the right moment to try to port that. But at some point, maybe it could make sense for other clients like Guillaume or maybe you in C++, you will find some difficulties to call like the leanVM in Rust. So
Okay. Can I just put an alternative to porting on the table? What you can do is put the no mangle attribute on each externally facing function in the API and put extern C, and you can write a C header file, and that will result in the Rust functions looking like C, and then anything that can call C can in principle call them.
I mean,
I think that's already done.
That's more or less already the case.
But I think this will not solve your big compilation time problem. No?
But definitely not the compilation time, but more the duplicate symbols or the problem of language incompatibilities are still going to be.
So are you compiling them to a static library, and then merging them into the Yeah, so I tried to, at one point, fix some duplicate symbol thing. On the compiler side, there is something called identical code folding, ICF, that can scan the code, and if they see that the output is the same, it merges them.
Right.
But it's a feature that sometimes it's compiling, sometimes it's not, and I never managed to fix it. Right. But I only spent like 2 days trying to look into that. But codes, and also they have something called GC sections, function sections and data sections,
Yeah.
and this can help those do garbage collecting, etc. But already you write a custom linker. But we had that in Valida.
Yeah.
So we actually had the compiler engineer to do a custom linker script to remove duplicates.
Oh wait, is it the linker script or?
You can do a linker script to do this. I think
You can.
I think yes, because when you I don't know with ZXCC, but with LLD and mold, you can pass a linker script, and if it's just duplicates, maybe we can pass a linker script to analyze duplicate functions.
But wouldn't it be easier just to say, wait, we have one official multi-lib where we put all the reference implementations in there, so we only link to one Rust lib, so we don't have this issue at all?
For me, I think it's easier to have call it REST if, and you put all the stuff that you depend in with a single export.
So that would be working for just XMMS and like maybe leanVM and things like this. But in our case, we need to rely on Rust P2P, which means we need to drag the whole thing. I don't think Go, for example, is going to be interested in this. I don't think C++ is going to be interested in this. So we have. I mean, we're not interested in this, but we need it.
But you can maintain two repos, one with just the cryptography,
right,
and one with cryptography plus libp2p. And once you have libp2p in Zig, you deprecate the other. And once you have the script to do cryptography, having cryptography plus libp2p works. And if you somehow need another Rust library in the future, it's easy to add them.
Okay, I'd say my favorite approach would be to see if indeed those linker scripts. So I've never used linker scripts in this specific instance. I'm quite surprised that this is even possible. If it is, it's awesome, and we need to use it because I think that would solve the problem. If we can indeed do this, then I think that's the best way, so that we don't have to.
But isn't that a different problem? Like the duplicate symbols will also happen if we put everything in the same static library.
It would not, because if you put everything in the same static library, you would still potentially get some problem with LTO, which is more or less what you described. They're trying to look for locations they can deduplicate, which we also had to disable. I didn't mention it on my slide, but it's a fine. But yeah, you would not have the duplicate problems because at least a lot of the duplicate symbols are actually the basic Rust standard library things. So if you build a single .a file that you can merge, then you don't have this problem, which is already a big gain. But before you get there, I wanted to change my hat from Zim to Geth.
Yeah, maybe this is very interesting that you give us all of your experience about Geth with this kind of problem.
Right. The thing is, like I was saying earlier, Rust doesn't play well with others. Go is even worse at this. And Go just interacts with C, and that's it. So you can always get a shared object file, like a dynamic library, and get it to Go to DL open it and load it in memory and do all these things. I don't know about Prism, but as far as Geth is concerned, this is no. This is just no.
I managed to compile Go with Constantine by compiling Constantine to a .a library. So if we do a static library, it would work.
Right. A .a. Okay, yeah, that's true. If you can use .a in Go, which you should be able to, that works too. Yeah. Okay. It's just that. Like there's an external builder if you want, and once again, talking about Geth, we don't really like that because we want to be able to have the control over all the tool chain. We don't want to build some something in a language we don't quite understand,
So,
because if we need to debug?
what can be done is that library can be how do you call that? That library altogether that has everything can be compiled nightly and distributed, put on GitHub as an artifact. Yeah. So once you build, what's the name of Beam get or something, you just download it. So this way you don't have an external compiler just fetching resource.
Yeah, but you need to manually fetch it. You can't just do the Go. Like it's going to break a lot of of workflows basically that have to be rewritten. And I'm not just talking about Gears. It's not that we're lazy.
Or maybe
there are people.
Maybe it's in Git LFS, so that when you git clone, it's there.
LFS.
Large file.
Oh, so you want some kind of submodule? You mean?
Yeah, for example.
I mean, it would technically just be committed as a file to the repository, but it's not stored in the regular way Git stores binaries, but rather a different approach, and then Git just knows how to call the file.
Yeah. So I'm just saying, historically, I mean, this is not the first time we're running into this thing. We said no. I would not be able to tell you exactly what was the reason, but it has to do with I mean, once again, some external thing we don't quite control. And it's all about who wakes up at 3 a.m. to fix things when things go wrong.
Just a quick question for the multi-lib approach, right? Given that you talked about also having to interface with some of the zk-VMs, wouldn't you then also have to put code for that interfacing into that multi-lib? Because you were already talking about libpk, etc.
Yes, absolutely.
So that makes it very, very specific to, let's say, your use case, and not useful to anyone else, right? Because not everyone will have to interface with those particular zk-VMs, etc.
I mean, it depends. Yeah, I mean, indeed, because for example, we only support like 3. Yeah. Presumably, the day RIM wants to do this, since everything is written in Rust, although they will probably run into the same language versioning problem, they will have a lot more, so they're even more likely to run into it. For Ethereum, I don't know, how that's gonna work with them, but yeah, I think it's going to be the problem. So what we could do is one release of a client per zk-VM. So to say, like, this is the version of Zeem that only supports RE0. This is the version of Zeem for Zisk, blah blah blah. But yeah, I mean, it could be done. It's just not very practical to have multiple binaries to juggle with.
So I have another possible solution. So it is possible to take a library and like object file and add a prefix to every symbol in that. So if you do that, that will get rid of all the name conflicts. And if for example, like the Rust portion happens to even be using a different libc than the Go portion or whatever you're linking it with, that could still work.
So I thought about that, but how do you force Rust to rename its?
Well, you can just use a command called obj-copy. You can take the compiled library and run it through obj-copy with this prefix symbols argument.
Okay.
But then when you link to that library, like, then how does the calling code, let's say, like, you would also have to patch that to actually.
Well, you would just need to use the appropriate prefixes when you call its functions.
Right.
That just doesn't work.
Yeah. Well, you just, like, in the C header file that you make for the interface, you just add that prefix to each name in the header file.
But okay, we can definitely trade this within the Zig build system. That's not a problem. Calling obj-copy, everybody has obj-copy on their. Okay, everybody who has a working compiler has obj-copy on their system. But at the same time, is it really more complicated? Is it really much more simple than implementing a C version of each library?
I think it's way simpler. It does result in more code size.
For now, leanVM, all the stuff done on the lean side, they don't seem that big. But you don't want to re-implement RISC-0, SP1, or OpenVM in another language.
Right.
Yes, there are two problems there. Yeah, leanVM doesn't sound that big, this is true, but behind that you have all of the primitives that are quite big, because for example, when you in leanVM, when you call like the air builder or like the Poseidon or the field multiplication of clunky 3, it seems like this is nothing, but this is really huge.
This is already implemented in C and C++, because RISC-0 and SP1 are using Spark, which is implemented by Supranational for their GPU acceleration.
Okay.
And there is also the team that does Tachyon, which is a GPU accelerated proof system, and they implemented, they started with elliptic curve, and they implemented Fry, etc., fully in C++. Though the build system is a mess because, well, they use Bazel completely, and it's just a pain. But there is code in C and C++, and apparently Weir is similar to Ligetron or something.
Some similarities.
And so the Ligero team has also Ligetron, but implemented in C++. So
yeah, we want also to make sure that we have the same optimization. For example, I don't say that they are not optimized at all, but for example, we did some neon optimization, some SIMG very like low level stuff. We just want to make sure that the performance are the same with. I don't say that this is not possible. Maybe even this is more performant. Like, I don't know.
But I think what's important is that for the verifier, anyone can run, and for the verifier, like maybe they run Zim, etc. And for the prover, you can just say, and that's the case now with Geth having the most performant cryptography compared to other. That you have 20% or 30% per difference, and we will solve it in the future.
I guess the other issue with having ports of the crypto libraries to different languages is if you ever want to change it, you're now multiplying the work that involves, the testing efforts, and you got to make sure all these implementations work with each other, that if you generate a proof with one, the verifier for all the other ones will verify
yes,
it.
But that's something that's always been desired at the EF, to have multiple implementation until we have formal verification. Like, as long as we don't have formal verification, it's desired to have client diversity, because even just recently, 3 weeks ago, Ref had a bug on mainnet, and it stopped all proving systems, and the mainnet, it stalled on a block on some corner case. So actually having multiple implementation, I'm not saying 9, but 2, 3 is a plus.
Even with FD, I would say that's a plus, because with formal verification, you still have the issue of, did I in fact express what I intended to express with the theorems that I proved? And having different expressions of the same thing can help with that. Like in the Apollo mission, they would have the coders, every section of code would be written by 2 engineers who were not looking at each other's work, and then they would compare each other's work, and if there was any difference, not any difference in behavior, but any difference in the code, in what they wrote, they would talk about it until they agreed about what was the correct way.
And didn't that run also on 2 chips that were different, just in case there's a bug?
Chips were fitting, the size of the chip was a room, so they only had one application there. But this being said, having worked for EADS, today you have different computers, but they're all the same architectures.
Okay.
But I think, from my gut feeling right now, is it probably would make sense to, in the short term, to use the reference implementation, because there is still reference. So in the short term, I think we probably won't find any other way around using Rust. But in the long term, I think porting things to different languages makes a lot of sense. So it's just a question of when we're gonna be ready to start porting, for example.
Right. I think that you told me also yesterday that you have big compilation issue also, even like on the short term. You told me yesterday that it takes like 20 minutes to compile or something like that.
Right. But
the other thing is that if you want GPU acceleration, you can't use Rust. Anyway.
Really?
Oh, there is no GPU.
So Rust compiles to CUDA, but somehow it doesn't work. Which is why all ZKVM are using C++ for their implementation.
Interesting.
They all have like an exchange mechanism between the Rust and the C++, so they have like all of the CPU tasks in Rust and everything GPU in C++.
I see. Yeah, so, okay, that's good to know.
And Zig has GPU support.
Yes. Yes, so use Zig now, please, you know. It interfaces with C.
Does it have types?
It does.
Yeah.
It has strong types, compile time, evaluation. The async, I think they changed it, but the previous one was named.
U256 if you want. Yeah.
Memory safety?
It does.
Yeah, and you took 56 natively.
Why not Zig?
Yeah.
Because I use NIM.
Exactly. I agree with that.
Well, compared to Rust, why not Zig? Is there a reason?
Lots of library already existing, so like it's a pain to implement. If you want to re-implement everything, it's much
But
easier.
the Zig cryptography ecosystem is actually really good because the guy who wrote Libsodium, he's a core Zig contributor, and he re-implemented all the cryptography there.
In STD.
And the founder of HashiCorp is also a Zig fan.
Right.
And
Yeah, I know that.
so it's a good language.
It's got a lot of tailwind. But yes, you could, I mean, there would have to be, okay, this is not what we are advocating right here. There's clearly a good reason to do it, but we're not going to push for that right now. What we want is to just find a solution, and indeed, it's mostly a short-term problem because in the future, we expect to re-implement some of those libraries in Zig, but Zig, C, whatever is the easiest. Zig plays really nice with C, so even if C is the target, that's good enough for us. But what I mean is, yeah, like we need to make sure that we can actually not be stuck with Rust for leanVM and all the specific core dependencies. And it's not just, once again, Zig, it's also Go. Go is going to probably come into the dance at some point, and we're going to have to play with that. And that's honestly what I'm more worried about.
In NIM, we have a code generator for CUDA, and with GPU, we can add a code generator for C.
Like I said, let's talk. It's fine. We can do this. The problem with NIM is that every time I tried to install it, it was super complicated.
No, but here I would generate the C code, and you just import it.
Build complexity can be managed pretty effectively with Nix. That allows you to have reproducible builds where you can just, on any system with Nix installed, run Nix build, and you'll get essentially the same results you would get on any other machine. It also helps with build times by having effective means of caching.
Yeah. I don't know if you followed the news recently, but Nix has a huge problem. It's tearing itself apart right now.
The political problem.
The political problem. Yeah.
All right. Might not be the right time to adopt it.
Right. Otherwise, it's awesome, but yeah, I'm not. Currently, I'm gonna wait for this one to blow over before I spend more time learning all these things.
That's too bad.
But yeah, no, it's a great idea at the core. I hope they prevail. Well, wait, actually, so you would use Nix to do reproducible builds for what purpose?
The .a library, for example.
The .a library, so everybody could reproduce the .a library. Okay.
Well, and if the things that have that as a dependency are using Nix, then that also makes it easier to manage the build time issue, because you would be rebuilding the dependency when you need to pull in a new version, but not otherwise.
Maybe it's a good idea to write like.
Sure.
Is there like alternatives to Nix that do roughly the same thing?
Reproducible build is it's a hard problem. At FOSDEM, which is the biggest open source conference in Europe, you have now reproducible build track since 2023. They talk about Docker, etc. But you've always had issues with a compiler that put a timestamp as a comment, and now you have a broken reproducible build.
And also, I think Nix, part of the problem is also like the politics side of things, right? And there's Flakes, for example, which are experimental for a while now, and there's no agreed system to, do the right thing, so to speak, right?
And potentially because all of that is sourced, and yes, people are busy with other topics than security at the moment. You always have the risk of a supply chain attack. That's the other problem.
I think that if we have right now we are on this, right?
Right. Yeah.
This one, I think that they are relatively small.
The PGP one is not small.
Yeah, but that's
Are you using the which Rust MPP you use?
Rust.
Yeah, there is also light PTP,
But
which is a
also-
smaller version of.
LibPTP will evolve
Okay,
because
good
they
to
are trying to create new protocol as we speak.
Yeah.
So it's not small.
Okay, so this one is very small,
leanVM is small,
But
a bit less small, like I think. But
but it's smaller than libp2p.
Okay, so if we are like a classification, this one is the smallest, this one is the second smallest, this one is 3, and this one is the biggest.
yeah, I mean, there's multiple of them, and they're huge.
So I think that for this one, we could re-implement maybe multiple language. So maybe we would have like a Zig version, a C version, or a C++ version.
Yeah.
I think with Sebastian we could re-implement it in NIM, CodeGen, CUDA, WebGPU, and C. And the C part can be ingested in Zig, Go, etc.
Yeah. Go. Yeah. Sure. Yeah.
No? Yeah. I think adding a code generator in C should be.
I mean, it would be straightforward. Like the only thing is, like, given that the code generators so far they're all targeting GPU. In theory, that doesn't change anything.
Yeah.
But it just changes slightly the mental model of some of the stuff. But it should be straightforward.
Because here you only have like the field. After that, I just use the store. Here you just have like the final field and the post agent.
We already have that.
So like, to be honest, like with all of the context that there is in the Rust implementation, you just have ask code or ChatGPT, and it will transfer you in language, and then you fine tune everything. But that is not the case for all of them. So for this, for example, your current solution is that you just call the bindings, I imagine, compile everything for the ZKVM, wait for Rust to compile and all of this.
Exactly.
Wouldn't it be possible to have some kind of API socket or something and create that as a separate binary?
Yeah, we could do socket, of course. I've thought about this, but the problem is when you start having multiple binaries, you have it's a distribution problem where this is not what we want to do, but if we absolutely positively have to, we'll manage. But if you can't just copy the Zim binary somewhere and expect it to work, which is what you can do right now. You need to grab all the side binaries and everything. But at least in the case of ReZero, this is already what happens. It goes over a socket to talk to its prover.
So for me, it's natural to have the ZKVM prover or verifier as a different binary run on the socket so that you can evolve them separately.
Yeah, the only thing is that now I would have R0VM, my binding thing, and then Zim that says, oh, I cannot find the sockets.
But why is it already like that for RISC-0?
No, it's not already like that.
I thought you just said that for RISC-0.
Right. So RISC-0, what their bindings do, when you compile your host program, as they call it, it goes over some socket to connect to a program called R0VM, which I don't exactly know what it does, but the high level thing is it runs your program in your RISC-V programs, it builds the proof, it returns the proof. And that's already an external binary. But now what I say is if we do what Mami just said, we have two binaries to handle, and then if every ZKVM works exactly the same, then I have a binary galore.
Even in SP1, I think the part that reduces the stack proof to a snark is a different binary, for example.
As well?
I think it is, yeah.
We don't have SP1 yet, so.
Okay.
Yeah.
Let's imagine that we have that in Rust for now.
Yeah.
Like, what is the current proposed solution, for example, to go to Z, to C, to C++ or Go? We want to propose what maybe?
I mean, I can tell you what I suggest, but okay. Well, clearly, what we want ultimately is not to make this worse, right?
So you want to transfer that in Z?
Right? In Z, in Go. I mean, Go it already exists. It is the reference implementation. So that's Go wise. It's
there is one in C++ being built. No.
There is one in C. There's one in C++.
Ah, it's you. Sorry for giving you work.
Absolutely. That's precisely fine. We still have the client diversity thing. We also don't want to reuse the same library. This is also why we don't want Rust. It's because it's already being used somewhere else. And
we had discussion yesterday with Raul. I asked him, does it make sense to have maybe a single implementation and then index to this so that multiple clients use the same library? And he said, no, it doesn't make sense. Because networking stuff is super specific. For different languages. So most likely we'll have different libraries for libTP.
So what we were saying here is ZKVM, we also take this out because we use a socket. Okay. Actually right-handed, sorry. Socket. But then the leanVM, in my ideal world, this is also implemented as the local language. And there's a socket, but there's also the obj copy approach that I'd like to.
Simple prefixes,
If that works, I'm definitely going to try. If that works, we okay. At least that solves our short-term problem, and then we can.
But you still have the problem of the build script, where you have an external tools to build.
Yeah, but it's not as much of a problem because when the problem is if I modify a file here, I have to rebuild the whole shebang. That's the problem. Especially if I touch the cargo.tomo, bam, it recompiles everything.
For example, when we change the version of Rust, this is very frequent. Then it's modify all of the cargo.
Exactly.
Yeah, and give him a very long to compile.
Whereas at least with this approach, I can compartmentalize everything, like the obj copy or the socket. And so if I change something in leanVM or whatever is happening, at least I don't recompile everything. So that's a plus. Go will still have some issues because they still need the C version of all that stuff. Okay, no, they don't need Go. They don't need Go for this, but they need those two things. So that's going to be a problem.
What is the exact gain of maybe can you draw like the object copy path? How this works precisely? Like.
Well, sure, yeah. So you have your ELF file, right? And it's going to have some public symbols, like some externally facing symbols, and then some internally facing symbols. So, wow, this marker, something's wrong with it. Anyway, so like let's say you have this public symbol, let's call it prove, right? And then you have like a private symbol, like let's say malloc, right? Something in libc. The problem is, you want to link this, right? But maybe there's also a malloc in the thing you want to link it to. So you'll run this command in the Unix shell, and you pass this argument that's like prefix symbols equals right, leanVM underscore, and now you get an ELF that has right leanVM underscore prove, leanVM underscore malloc.
Yeah, it's the malloc part. That's the. This is what we don't have control over.
So now you can link this in without a problem at the expense of more code size, because you have two libcs and two of everything that is also in what you're linking with.
Does it resolve like your compilation time problem?
Yes, it also doesn't change the thing. Like when you say the binary is bigger,
Yeah.
I had to deactivate LTO anyway, so the binary is bigger anyway. So that's not gonna change the thing for that. Yeah, no, like I was saying, if we can make this work, then I can break that into different pieces, and it's making it easier to. I mean, for the Zig implementation, it's gonna make things easier.
Okay.
It doesn't solve like the approach for Go. Go still needs to somehow get some C stuff or some A library like .a, but yeah, it's gonna solve.
Just the title of the session was bindings.
Yes.
So I suppose we were also supposed to talk about the interface API that leanVM or XMSS.
For XMSS, but it's very simple. There is like a trait right now that is keygen, sign, and verify. So you just key generation at the beginning. Yeah.
We need the C names of those.
But I guess this will be like kind of derived from that. But there is just three functions. There are just three.
And for leanVM, what should be exposed?
I think it should be just prove or something like that.
And verify.
Yeah, prove, verify.
Commit.
And we need like some types. So like in the C header file that's going to constitute in the C header file that's going to constitute the FFI, we would need like some struct definitions or something of that nature, so that the leanVM prover and the code that's calling it know how to talk to each other.
I think we can just put context, which is just opaque pointer, and you init, and that initiates the context. And then you do your aggregation that generates aggregate and proof, and you also have a merge to merge two aggregates together.
Yeah.
And this way, when you do implementation of leanVM, everything that might be implementation specific is hidden behind this opaque pointer.
But I mean, that only works if you actually only use the stuff returned from any of the foreign functions inside of other foreign functions, right? So if you don't have to do anything with that in your local code.
The reason why I would do init with a opaque pointer is because sometimes your init will initiate also a thread pool or your GPU, etc. And it can be on CPU it can be empty stuff. And the rest is supposed to be stateless when you aggregate signatures anyway. So.
For about the binding for XMSS, this will be like these three ones. So you have the key generation at the beginning. This is very long.
So, but for example, when you do run the keygen, like the keys that you return, are they going to be necessary in the context of the caller, or are they just going to be passed over to?
This is your big,
Yes, that contains all your private.
You keep private key, a lot of them, and then you just store that as a validator. So yeah, that's your. For like you can generate that for a given number of slots or a given lifetime, and so you have this big vector.
But then you need a serialization format.
Yeah, we have a serialization format. We have like a derived serialization.
But my point is like once you have those, you will only pass them into, for example, the sign function or whatever, right?
Yeah,
so you don't actually need them in the caller.
Yeah. That is kind of a long process. We need to optimize this, but the last time that we benchmarked that, it was like a couple of months ago. I am sure that it has evolved and it will evolve because we have this problem of lifetime. We said like a couple of years because then you have to regenerate after this lifetime ends. You have to regenerate all of the keys. So it was like 10 years or something like that, and it was like 2 hours of key gen or something like that.
Okay. Like how many keys are you generating there?
And 1 per 4 seconds?
Yeah.
1 per 4 seconds.
Yeah, you can do the math there.
Yeah, like in principle, that's just like a random sampling situation, right? You just sample random data and
to key gen?
Or not?
Yeah, no, you have to do some hash and some.
Is it HKDF?
Okay.
For the randomness?
The key generation is HKDF extended.
Not exactly. Yeah. This is like you have a random generator at the beginning, and then you have
compute the Merkle features. Oh, I see.
So it's kind of.
And the slow part is then in the Merkle tree construction at the moment, or?
Yeah, Merkle tree because you have the hashes, Poseidon or stuff, so it can be quite slow. Yeah, I think this is the main stuff. We have some nice trick about parallelization there. We can also apply SIMD if this is not applied currently. So I guess that we can reduce that by some factor, but it will be kind of not a 1 second process.
I mean, it seems like for this, for example, having a GPU accelerated version could be A, very simple to implement, and B, give you a huge.
I'm not sure because it might be serial by nature. That your key n+1 depends on key n.
Why would it? Because the keys in principle they are independent, no?
Yeah, but I'm not sure that this is possible because we want like the validator to run on a very, very small devices. So
I see.
Yeah, because like in this validator set, you will have like a lot of validators, like just instead running on Raspberry Pi pq2, and you have 10% of them running on as an aggregator on like high-end CPU laptop. And this one will aggregate signature.
Are the user's wallet signing keys also going to be these PQ keys?
Yeah.
Okay. Well, maybe for them it would be useful.
Yeah. Yeah, but this is a very simple API. For like the leanVM stuff, like we have like the aggregation, so that will be basically like enshrined and abstracted into the stuff. But basically, you can have like multiple like you have two possible things for the aggregation. So you have like lots of signatures, signature 1, 2, 3, like that will be aggregated by an aggregator. So the aggregator will consume this 1000 signature and it will output like a proof. And you have also this other possible situation where you have like proof 1 and the other when you have proof 2.
It gives a proof and a signature, aggregated signature.
Just a proof.
Just a proof?
Yeah, just a proof.
And so this is mutated?
Yeah, you have it's a proof and like a bit field like represented like because each signer is 1 bit.
Mm-hmm.
And then it represents like a proof plus like a bit field of saying sign. And then you have this second proof coming from another aggregator, and then you have another aggregator that is responsible for aggregate this and produce a new proof. Okay. So you have these 2 possible scenarios, but that will be abstracted by the whole VM. And so probably the only stuff that you will have to consume in the leanVM will be kind of a proof function or maybe 2 different functions for
I think you should have aggregate and merge.
Yeah, we have a program that is called aggregate and merge. But maybe this will be enshrined into a single program with an if at the beginning, something like.
It's better to have two different things, I think, as public API, because it's not the same type, so you can do, and also for testing it's easier to have different test scenario. And the only thing I recommend is to even if on CPU it's not needed, you initialize opaque context object so that implementation are free to add thread pool initialization inside, GPU initialization inside, etc. And others that don't need it can just be empty function.
Just one question for the leanVM, I also expect as a verify function, especially when I think about light clients, usually they don't need a proof part. They only need the verify part, and the verify part needs to be as small as possible. So I'm trying to think if it's probably, it might be a good idea to say, well, maybe porting this explicitly, just to verify might be a good idea. Because code size doesn't matter for a validator usually, but it matters for a light client.
Yeah, and it will matter also like for the validator because like we will have like lots of clients, lot of validators running on very small devices, Raspberry Pi Pico, so it will be like a very small limited device. And on this one, you can't run the leanVM, so you can just run the verify part.
Yeah.
And so this will be important, and maybe this will even be as a separate repo. Like we will have like a leanVM verification repo where we will just put the verification program corresponding to the leanVM.
Different crates.
Different crates, yeah. What it wants. Yeah.
Just the Raspberry Pi is not a small device. I mean, if you're thinking
Pico is
Pico,
$10 device.
Okay, yes. We're also almost at time.
Almost at time. There's one aside question. You mentioned the aggregator doesn't sign. Could you quickly repeat why doesn't the aggregator also sign?
Sorry, what?
What Memi asked. Like you said, the aggregator is only like proving, like creating a proof. Like why don't? I thought they also signed.
I think at the end they will sign, but this will probably maybe not be part of this API.
Oh, okay.
Oh, so yeah, we need to check the separation of the API. Let's say, I say.
We have another 5 minutes, so Guillaume, is there finishing?
No.
Conclude.
Was that the last slide?
Yeah, so the last slide I was.
I knew we were only at 2 slides.
Yeah, 2 slides, but what's interesting is that we spent an hour and a half on 2 slides, maybe just an hour. I just wanted to, asking, that was just to start the conversation, but the conversation started itself anyway. Either you rewrite something in C, which I think is an option for at least the smaller libraries. Otherwise, we already mentioned that we build libraries. I just wanted to give the example of KZG for Geth, where we have the CKZG that we don't control, but it's the faster. But if for whatever reason there's a bug in there, we can switch to Go KZG, which is smaller but is different, so hopefully it doesn't have the same bug. And this is what I was going to say. If you want to do more than one library, if you want to use external libraries like you suggested, there should be at least 2, so that in case one of them has a bug, you can, in an emergency, switch to the other one, and don't not kill the consensus while the bug is being resolved.
But when I looked at Go KZG last time, I don't think we support PeerDAS.
It should. If that's not the case, then we have a huge problem. Open an issue.
Because I'm implementing PeerDAS at the moment in NIM. So I was looking into this, and but there are 2 Go KZG, one from Proto Lambda and the other from Kev.
Right.
And one doesn't support PeerDAS.
Okay, so we have to figure out which one it is and which one we're using. Okay, I'll need to talk to you after this session. Yeah, so as a conclusion, I mean, thank you. First, I think we got a good series of options to explore. Yeah, any last word? Any last comment?
Good luck.
Thank you.